This is Mr. Hannon. Welcome to What the Format. Today we're going to go over we're going to start making the transition from Algebra 1 material to Algebra 2 material. Now in Algebra 1, in the videos you've seen, I've covered a few different functions. I started with linear functions, and one of the subset of linear functions is the constant function. That's just your flat horizontal line. We saw a specialty case where we had vertical line. So horizontal line, vertical line are special linear functions, except for vertical line is not actually a function if you're thinking about it because the x repeats. So constant function is the horizontal, and you've got a line with either a positive slope or a negative slope. Okay, then you go into quadratics. Now from there, there's a lot of other things that they can go, and depending on where you're at in these curriculums, it used to be that they were pretty set in how they followed them, but now the curriculums are different. A lot of Algebra 1 classes will do absolute value of x. Some are now doing exponentials, and that's why I did exponentials. The curriculum at school I'm at is doing exponential functions in Algebra 1. I'm not necessarily a fan of that, but once the curriculum is set and you're at school, and that's what students are learning, that's what you cover. So exponential functions, but basically, what are functions? Okay, recall that the definition of a function is that each x, when you plug x into the equation, you only get one answer back. Now, that y doesn't have to be unique. You can get an x of 3 and a y of 2, and then for x is 5, you can get 2 as well. So the y can be the same, but the x is, you can't get two different y's for the same x. So if I plug 3 into an equation and get 2, and plug 3 in and get 5, that's a problem, okay? Now, with the functions, there's what's called a library of functions. This is where the transition from Algebra 1 to Algebra 2 starts to go, okay? And actually even kind of pre-calculus, okay? If you know where you're headed with what you're learning, it makes it, in my opinion, easier to pay attention to it. So let's go back to why most students are struggling with math when they get into middle school. It goes back to third grade, okay? If you don't memorize your math facts, and then you are asked to do 3, 9, 4, 5, 6, 7 times 9, 1, 8, 3, okay? You can't do that in your head. Now, most students these days will just plug that into a calculator. That's a problem. Why? You need to be able to break this down and handle it a step at a time. This is in third grade math when you first start learning to apply an algorithm to a problem that allows you to solve multiple problems. So, at this point, it doesn't matter how many numbers I put here to multiply by, I can just go through them one at a time until I get the answer. Now, of course, really, really large numbers, I need a lot of space, and maybe it takes me an hour to do it by hand. And obviously, we don't want that. That's where calculators and computers come in. They do the math faster for us. But if you don't know how the math is being done by the computer or the calculator, you're in trouble. Because then if the calculator or computer makes a mistake, you're not even going to have any idea how to fix it. Okay, what happens if all calculators and computers on the planet just stop working all of a sudden, which is not without the realm of possibility. EMPs, electromagnetic pulses, tend to make electronic devices not work. Then you got to do things by hand. Well, what if you can't do it by hand? Here you go. Okay, so when I see this problem, all I see is the 3 times 7, 21 carry the 2. And then I just go down those same steps all the way. Of course, now I have 3 times 6, 18, and I have to add the 2, which is 20, carry the 2. See, but now I can go through, and I just go through the 3, all of them, distributed property, 3 times each of these. Then I go to the 8, but it's not really an 8, it's an 80. So what do I have to have? A 0. That's not really 1, it's 100. So I need a double 0. That's really not really 9, it's 1,000. And now I know where to start putting my numbers. And then when I'm all done, I just add them together. Okay? Now, that is an algorithm. You learn this in third grade, and that prepares you for when you start to go up. So we're learning functions because there's a library of functions. When you get to pre-calculus to calculus, I think I've counted, depending on some of the functions they leave in or out, there's about 16 to 18 functions that you have to be aware of how they work to do calculus. Okay, and I just worked with a student who was doing a triangle. Yes, a right triangle. So what formula are you thinking with the right triangle? Well, we think Pythagorean theorem, ladder leaning against a wall. Okay, so x squared plus y squared, there's your x, there's your y, there's the length of the ladder, so we'll call that L equals L squared, right? But the problem didn't actually want that. It wanted something to do with theta. And for a lot of you out there, especially if you were below Algebra 2 and you've not taken trigonometry, you don't know that the sine of theta equals y over L. See, that's a function. That's an equation. Okay, Pythagorean theorem is a relationship that exists in a right triangle. So is this right back trigonometry? These are defined based off of a right triangle. So now all of a sudden you're mixing all these things together. So if you've forgotten certain aspects of things when you were at the lower levels of math, when you get to the higher levels of math, it starts to become a real problem. Okay, so in a library of functions, the key is to know your function rule, which is usually f of x. Of course, we could also use g of x, h of x. Don't get locked into the f so that if they change it, you can't see it. But now you got your function rule. So the first one is a constant, so just some c, right? And then we have our base function f of x equals what? X. F of x equals x squared, okay? So you can see if you follow that pattern, you have x cubed, but you could really just say x to some integer value, some natural number, okay? This was x to the 0, so I guess whole number, but 1, 2, 3, 4, 5, all the way on down. Now, typically, in Algebra 2, they stopped at the cube, so we'll stop there. But you can see that technically that pattern can go on forever, okay? Well, why do I need to know these? Because each one of these has a domain and a range. And one of the common things that they like to do is ask for domain and range of a function. It's very, very common. Of course, there's the domain and range of the actual function rule, or base function, or whatever the rule has to be, but then there's also the domain and range of a changed. So one of the things they love to do is they love to give you a line with a closed dot that goes up and has an open dot. And you now have to get your domain and range. Well, one of the things students do a lot of times is they confuse the two. Remember, your domain is your x's. So this is my domain from here to here. Now, let's say I don't know what this is, so I'm going to call it A, and I'm going to call it B, right? A to B, just some interval, okay? Open dot, okay, for my domain, A is on the left, less than or equal to x. Why? Because I'm going to the right, so x is greater than or equal to this number. And I know you're like, well, Mr. Handy, you put the less than or equal to. The less than or equal to is pointed this way. Where's the mouth pointed? To the x. So you read this as x is greater than or equal to A. Recall an inequality, wherever the mouth is the greater. So whatever's over here is greater than over here. Whatever's over here is greater than over here. That's where they start to change things up a little bit. It looks a little different and students get confused. You have to learn to memorize all these little variations of a rule and how they're used so that when they're used in a testing situation like they use on the ACT, the SAT, MCAT, LSAT, all these different things, they mix things up. They're trying to not confuse you, but they want to see if you can really think through a problem. And unfortunately, a lot of people can't do that anymore. Young people, so they get really confused. Domain is your x value. So there's your greater than or equal to. That's a what? Less than b. Now, of course, if there was a real graph there, they'd probably change those numbers. I mean, they may make that, what, -6, -2, -1, whatever, and that could be positive. And both numbers don't have to be negative, or you don't have to have a negative and a positive. You could have on the positive side and the negative side, they can mix up. Now, what about the range? Okay, the range goes this way. See that? Okay, since I'm going up here, I'm greater than or equal to this. So there, I'm still greater than or equal to A, and now I'm less than, oh, but A and B don't work anymore, do they? See, that's where students get confused. See, and I started to do the same thing. If you're not paying attention, that's how they get you. Are you starting to see how this works? That was my X value. Well, there's going to be a Y value over here, which we call C, and there's going to be Y value over here, which we'll call what? D. I'm above C, so I'm greater than or equal to C, but I'm less than D. Now notice that the inequalities are the same. Why? Because a closed dot has the equals under the inequality. An open dot does not. And they will get you, okay? A bunch of students I had just took a quiz on Friday, and one of the problems was worth 2 points, and a bunch of them missed this part. They put greater than or equal to when it should have just been greater than, or they put less than or equal to when it should have just been less than. They missed that. They probably don't even know they missed it because we were in a quiz and it was a Friday before the weekend, and their brains were just what? Woo, right? Like how my brain was there a minute ago. Woo, I put A and B. Wait, it can't be A and B. Oh, I wasn't paying attention. I didn't catch myself. I put A and B there. Now I got it wrong. And here I am supposed to be teaching this stuff. This is how this works. If you're not careful, it doesn't matter if you know it. If you don't pay attention to these little details, they get you, they trick you. Okay? Domain and range. Now, that works not just for lines, because remember, the domain and range of a line, all real numbers, all real numbers. If they just give you a linear equation, as long as you can identify it as a linear equation, the domain and range is all real numbers. But then what they do is they start to mix it up. They put fractions in there and decimals, and so students don't recognize that g of x equals 4.61 minus 0.23x. They don't see that as a linear equation, but that's a linear equation right there. See, I have saying x, highest power, is 1. So domain and range, all real numbers for both. Okay, now if I change that and do a different function, okay, and I say h of x equals 4.61 minus 0.23 x squared. Oh, x squared, that makes that a quadratic. Domain is all real numbers. Well, what about the range, Mr. Anna? Well, that's a negative. See how it's a negative in front of the x squared? That means this parabola is going where? Down. Now there's no b term. So I know when this is 0, 4.61 is my vertex. So now my range here is y is less than or equal to 4.61. Now if there was a b term there, then finding that would have been a little bit more complicated, would have required more work. And that's how they get you. Some problems don't require a lot of work. You're like, oh, that's easy, I got it. And then they mix it up, and then you're like, oh, no, I don't got it. This is why you go through it. Library of functions. They all have a domain and range. So the first thing you need to do is memorize the domain and range for each, what I call the base function. Then, of course, there's the transformation of functions, and then you have to know, okay, when that shape moves around the xy coordinate plane, how does that change the domain and range? And you go through all of those and get those down, and then there's specific domain and ranges. But then I showed you, they have to give you the graph for that. So you have to be really good at reading off graphs. These are now skills that you develop and practice over time. Okay, so domain and range. Remember, your domain is your x values. Open dot is less than or greater than. Closed dot is what? Less than or equal to, greater than or equal to. Oops. Help if I put the equal to in the right place. Sorry about that. And then the range are your y values. Okay? Now there's different notation for these. There's inequality notation. That's what these are. There's interval notation. Interval notation uses parentheses for open dots. It uses brackets for closed dots. All right? And then there's set builder notation, which is a combination of set and inequality notation. What if they're using one you're not familiar with? Now you're in trouble. You got to try to figure it out. But usually what I like to do with a graph, I'll rewrite this graph again. So you got a closed dot down here, right? And then let's just go up here. So I change the graph, right? I usually like to go down here and read the x's this way. This is your x's, yes? And here you are what? Greater than, less than, equal to. I usually like to get that set first. And then you just read those numbers right off the graph. Well, what about the range? Okay, well, the range goes this way. Okay, and I got to get my y here, right? You're what? Greater than that value, so that's greater than or equal to because you're going up, and then you're below that value, so that's less than. And then now you just have to practice this. And if you get this down and they give you a graph, that should be an easy question on any test they give you. Library of functions. Obviously, I'm going to start to go more in depth. These are the basic polynomial functions. You got your constant function, linear, quadratic, cubic. There's other domain and ranges, okay? Of these, this has a domain of all real numbers, domain of all real numbers, domain of all real numbers, domain of all real numbers. It's the ranges that change. Here, these have a range of all real numbers. That's your range for both domain and range. These, the range is restricted. Why? Because this turns around on itself. So this range doesn't cover all real numbers. So it turns around. This one is just a flat line, so it has a single number. So if you see something like this, f of x equals negative 37. What's the range of that function? Well, that's the range right there. The range is negative 37. And they use the braces on that. So there's your range. And oftentimes I won't even put the y. They'll just put negative 37 like that. Okay? That would be the same for a vertical line. If your vertical line is up here, right here, and they say x equals 7, then what's your domain? Well, your domain is just 7. Sorry, sometimes my braces get looking a little weird. Let me redraw those. And there's your domain. Domain is just that one number. Okay? The range would be all real numbers for that one. What's the domain for this? Well, all real numbers. It doesn't matter what the going to always get negative 37 as an answer. It's just a flat line like this. So all these little variations they hit you with. If you're not paying attention and don't know how to think through it and don't pause, they get you. You get questions that should be easy wrong, and then it's not easy anymore. It's not hard, it's impossible. Most of the time you're not going to guess these answers. You have to know how to think through the problem. So I will start to do more videos on library functions. I've covered exponential functions, I've covered linear functions, I've covered quadratics. So I'm going to move on to some other functions, and at some point you'll see videos on each function. I'll go over the domain and the range and the base graph. Then from there, after that, there you got the transformation functions. But notice the transformations applies to all the functions. You can stretch or shrink vertically a function. You can move it right or left. You can move it up or down. So to do that, though, you have to know the base function to understand it. Okay? I have a marker. I can move left, right, up, down, right? If it's going up, I can flip it over. That's an x-axis reflection, right? I can stretch it. I can make it bigger or shorter. Okay? And then, of course, this is a marker. So other things, right? Like a box of envelopes has a different shape, right? A cup has a different shape, a bowl, a plate. That's the base shape of the function. I need to know those base, domain, and range, and then we can move it around in space, and that would change those things. A lot to keep track of, but it all comes back down to the domain is your x and the range is your y. And of course, like I said, we can change any graph. Normally a linear graph doesn't end. And if there's an arrow on one end, that means the graph keeps going forever. And then you don't have to worry about these inequalities, at least on one end. So you notice that one inequality, you can have two, like we had here, or I could have kept this going, right? Yes, and then that would have been x is less than or equal to would be the domain, because I only stopped it at one end. All these things you have to think about and consider. So now here's a good thing to do. You've watched my video. Yes, it's a long video. I'm sorry about that. But domain and range is a pretty big topic. Go out and start practicing problems. See what you don't know. Make a list of questions, right? You don't understand something, say, hey, I ran into this problem, Mr. Hanna. Attach it to the email and send it to me. I'll catch that, look at it, send you an answer back. And that's how teaching works. You look at something, you try it, you realize you're not quite get something, you ask questions, you go back and forth until it clicks. Unfortunately, a lot of students aren't learning that way. They're not learning, period. 3 weeks go by, they've forgotten something, and then when it comes back, they're all in trouble because they can't remember what to do. And I've seen that take as little as 2 weeks for a student. I had a student one time, got a nice 89% on a test, 2 weeks later an 82. What happened? Oh, they put one of these problems on there. I said, well, you know how to do that. I know, but I forgot. 2 weeks is all it took. And the grade dropped from an 89 to an 82. Forgetting in math is not good. Forgetting in math it's over. You can't solve problems if you can't remember all these things. Domain and range. Hopefully that gives you some idea of basic domain and range, especially when we modify graphs. Okay, kind of some domain and range here. You can go back over the videos I've done and see what those domain and range, but I'm preparing you for what's coming. It's going to be a lot of functions, and each function has its own domain and range for the base function, and then we go into the transformations. Anyway, hopefully this has helped. This is Mr. Hanna with What the Format. Happy mathing.